Okay, guys, sorry about that. I don't know what's happening with my network. Let's just get to continue. I'm sure I'll be able to finish up. So now we're now on question number 5.12. The question is saying, it is observed that the second ionization energy of lithium is considerably higher than beryllium. Explain this observation. So we have got lithium here, we've got beryllium here. So now, for us to explain this observation, we now need to see, or else we now need to know the number of valence electrons on what? On lithium as well as on beryllium. We can only know that by going to the what? To the periodic table. So this is where we have got lithium and this is where we have got what? Beryllium. So you would see that when it comes to lithium, it has got what? Three total electrons. So those electrons would be having two in the inner shell and one in the outer shell. And then for beryllium now, you'd be having two in the inner shell and then you now have what? Two in the outer shell. So you would see that the ionization of what? The first ionization of lithium is actually smaller than the what? The first ionization of what? Of beryllium. Why? Because we are saying that the radius, this radius is smaller than that one. So the ionization energy is greater for the first ionization. But when it comes to the second ionization now, you would see that when lithium loses one electron, it remains like this. It's more like it has gained an octet state, which is more of what? Of a helium, which is a what? Which is a noble gas. And we know that the characteristics of noble gases is that they've got a higher ionization energies. You cannot ionize them. They are reluctant to what? To react. So you would actually get to see that when beryllium loses, it will remain with two there and then one outside there. So definitely this ionization energy, which is the second ionization energy of lithium, would be greater than this one because now we are saying that the second electron from beryllium is still removed from the what? From the second outer shell. It is still removed from the second outer shell. Whilst now for lithium, we are now removing from the inner shell. And we know that the inner shell is closer to the nucleus than the what? The second outer shell. So let's get to see how we were supposed to what? How we were supposed to explain that. So here you're just supposed to come and say that you were just supposed to say that I want to actually create space there. Yes, let's create space like that so that we can be able to explain. So we are saying that the second electron from lithium is being removed from the energy level that is closer to the nucleus. That is closer to the what? To the nucleus. Compared to what? Compared to beryllium. So this makes more energy to be required to remove that electron from lithium than from what? From beryllium. So you would say, therefore, more energy will be or else is needed. Therefore, more energy is needed. Therefore, more energy is needed to remove the second electron, of lithium compared to beryllium. So we are saying that when it comes to lithium and beryllium, lithium is having an electron configuration which is like that because it has got what? Lithium has got 3 electrons. And then beryllium, it has got 4. So its configuration, let's get to draw the configuration of beryllium would be to say 2 in the inner, 2 in the out, because beryllium has got 4. So now when we remove 1, we are now going to be left with what? With 2 for lithium there. So these 2 electrons, they are now closer to the what? To the nucleus. Other than when we remove 1 there, for beryllium, you are still left with an electron that is in the outer shell. This electron is far away from the nucleus. So the energy that will be required to remove one of these electrons that is closer to the nucleus will be greater than the one that will be required for this one. So that is what we have just explained there. Now let's go to the following question. Now here the question is now saying, write down the name of the group of the elements that have the highest first ionization energy. We know that these, they come from group what? From group 8. So it's group 8. And that group 8 is actually referred to as what? As noble gases. It's from group 8, which is referred to as noble gases, or else group 18. Some, they call it what? Group 18. And then they're saying, write down the chemical formula for magnesium oxide. That is just magnesium would be having 2 outer electrons, and then oxygen would be requiring 2 outer electrons. When these actually react, they would form what? Magnesium oxide. So this is how, or else this is the ionic what? Compound of magnesium oxide. So this is the chemical formula there, magnesium oxide. So that is for magnesium oxide. For calcium carbonate, we have got calcium, which is 2 plus, and then we are actually looking for what? Carbonate, which is having what? We have got calcium carbonate, and then for calcium carbonate, this is to be equal to what? Calcium CO3. So you can see that here, this one would be having 4, and then this one would be needing what? It would be needing 6, and then this one would be having 2. So the oxygen that is there is the one that is actually going to give us that. So here we are going to have what? Calcium carbonate. Our calcium carbonate is just what? Calcium carbonate, like that. And then for iron oxide, we are also, so here they said iron 3. We have got iron 3, which is like that. And then we can have iron 2, which can be like that. Because if we have got 2 here and we are needing 2 there, it means to say that we can donate 2 to this one. But if we are having iron 3 plus, and then this one is 2, when we donate 2, this one would actually get to come here and that one will come there when we want to balance. So for iron 3 plus, that is what we'll be having. So the formula there for iron 3 plus. So I have to have iron 3 plus, like that. So that is iron 3 oxide. Now write down the name of, this is ammonium. So you would say ammonium. And then this is sulfate. So it will be ammonium sulfate. That is the name there, ammonium sulfate. Let's go to question number 6. Question number 6 is now saying, define the term 1 mole of substance. So how do you define 1 mole? You can either define 1 mole of substance as the amount of substance, the amount of substance that has equivalent, or else that is equal number of entities as 12 grams of carbon 12. Isotope. So we are saying that the amount of substance that has equal number of entities is 12 grams of what? Of carbon 12. And how much are those number of entities? We know that these are given by the Avogadro's number, which is equal to 6.022 times 10 to the power 23 entities. So you could have also defined this in terms of the number of what? Of entities. You would have just came and said that one mole represents, you would say that one mole of substance uh, represents represents um, 6.022 times 10 power 23 entities. So you would have said one mole of substance is the amount of substance that carries 6.022 times 10 power 23 entities. That is how you would have just defined one mole of substance. So you can choose which definition you want to go with. Now let's hear the following question. Now they're saying in the reaction below, 3 grams of what? 3 grams of sodium carbonate were reacted with hydrochloric acid and an effervescence is observed. So we know that when sodium carbonate reacts with hydrochloric acid, we are actually going to have what? A gas being produced, and that gas is what? Is carbon dioxide. Now they are saying calculate the molar mass of sodium carbonate. How do you calculate the molar mass? The molar mass, the molar mass of sodium carbonate is just equal to the what? The total atomic mass. The total atomic mass of what? The total atom, we can say the total atomic mass of this, which is the total molar mass of this. So we can actually come and say it is equal to 2 times sodium carries 23 plus sodium carries what? Does it carry 23 or 24? Sodium carries 23, and then carbon, it says it carries 12, oxygen carries 16 times 3. So we use our calculators there. The total molar mass there would just be equal to what? 106 grams per each mole. Grams per each mole. So you're supposed to give your answer as grams per each mole. Now calculate the number of moles of the 3 grams of sodium carbonate used. So number of moles is simply equal to mass over the molar mass. So here we come and say the number of moles of what? Of sodium carbonate would be equal to 3 grams divided by what? By 106 grams per each mole. And this was going to give us what? It was going to give us 0.028 moles. That is how you calculate the what? The number of moles there. So that was the answer for 6.3. You just say mass divided by what? By molar mass. Now they're saying determine the number of oxygen atoms present in the 3 grams of what? Sodium carbonate. So now we are just saying that how do we calculate the number of atoms of oxygen atoms that are present in the sodium carbonate? So you can see that the number of atoms of oxygen, we have got 3 oxygen what? Atoms in the sodium carbonate. So we have got 3 oxygen atoms in what? In the sodium carbonate. But we have got 0.028 moles of sodium carbonate, where we know that 1 mole of any compound has got 6.022 times 10 to the power 23 what? Entities. So we now need to actually get to say that if I'm carrying, so I would have just came and said for 6.4, if I've got 3 atoms of oxygen in this compound, and then I've got this number of moles. So the number of atoms of oxygen, the number of what? Atoms of oxygen will be equal to 3 atoms in the compound of sodium carbonate times 0.028 moles, which are total moles of this, times the number of entities in 1 mole. After I've done that, I would get the total number of atoms in this compound. And that we're going to be equal to what? To 5.11 times 10 to the power of what? 22 oxygen atoms. That is how you're going to calculate that. Now let's go to our last question. I'm sure it's question number 7. Now our last question is saying sulfur dioxide, which is given there, reacts with oxygen to form sulfur trioxide in the balanced equation below. I'm sure this is for what? For the contact process. In one such reaction, 2.45 decimeter cubed of sulfur trioxide is formed at standard temperature and pressure. State the Avogadro's law in words. So the Avogadro's law in words, it says that every gas, or else let me say that 1 mole of every gas, 1 mole of every gas at standard temperature and pressure occupies an equal volume. It occupies an equal volume of 22.4 decimeter cubed. So 1 mole of each gas at standard temperature and pressure, it occupies an equal volume. That is equivalent to 22.4 decimeter cubed. So every gas at standard temperature and pressure occupies equal what? Equal amount of volume. That is what the Avogadro's law says. Now they're saying calculate the number of moles sulfur trioxide that are formed. So now we want to calculate the number of moles of sulfur trioxide gas that are formed. Now we are told that we have got what? We have got a mole of, we have got a volume of what? 2.45 decimeter cubed of what? Of sulfur trioxide gas. And then we know that the molar volume of each gas is 22.4 decimeter cubed. So to calculate the number of moles here, we are going to say that the number of moles of what? Of sulfur trioxide gas would be equal to the volume of the gas divided by its molar volume. And we know that the volume of the gas is 2.5 decimeter cubed divided by the molar volume, which is 22.4 decimeter cubed per each mole. So this one was going to give us what? If you punch in your calculators, you were just supposed to get what? You were just supposed to get 0.11 moles. So the answer here was going to be 0.11 moles. So you say the volume that you're given divided by the molar volume. That gives you what? That gives you the answer for 7.21. Which is what? Which is just the number of moles of sulfur trioxide gas there. After that, we are saying calculate the mass of that of sulfur dioxide. Now we need to use the molar ratio at which these are reacting. So you can see that 2 moles of sulfur trioxide are reacting with 1 mole of oxygen to form 2 moles of sulfur trioxide. So if I know the number of moles of what? Of sulfur trioxide, I actually know the number of moles of what? Of sulfur dioxide. Because the number of moles of sulfur dioxide that are reacting are equal to the number of moles of sulfur trioxide that are being formed. And these are actually equal to what? 0.11 moles. These are what we have just calculated. Now to calculate the mass, we know that the number of moles is equal to mass over what? Over molar mass. If that is the case, we can find the mass by multiplying the number of moles by the molar mass. So we would have just came here and said the mass of sulfur trioxide gas formed. So this is now 7.22. We would say that the mass is equal to the number of moles times the molar mass, which is just equal to 0.11 times the molar mass of sulfur trioxide is just 32 plus what? Plus 32. So that becomes 64. And then we're going to get what? We're going to get 7.04 grams. That is the mass of sulfur dioxide that reacted. And then now they're saying number of moles of oxygen molecules that reacted. We also use the same the same equation to derive the molar ratio there. And we can see that the molar ratio is saying 1 mole of oxygen reacts to form 1 mole of sulfur trioxide. So the number of moles of oxygen would be equal to what? To half of the number of moles of what? Of sulfur trioxide. So we need to have half of this, which is equal to half of what? Half of 0.11. So we can now come and say the number of oxygen molecules. The number of oxygen molecules, how we will calculate them. Now we now know the number of moles, so 7.23. The number of moles of oxygen is equal to half of the number of moles of sulfur trioxide, which is equal to half of 0.11. And this was going to give us 0.55. 0.055. So this one was supposed to be 0.055. 0.0055. And now we are saying 1 mole of each gas actually carries what? 6.022 times 10 to the power 23 entities or what? Or molecules. Now, if I'm having 0.055 moles, how many entities will I be having? I just multiply by the Avogadro's number there, which becomes times 0.022 times 10 to the power 23. And then I know that the final answer there would be simply 3.31 times 10 to the power what? Times 10 to the power 22 molecules. So that is the value there. Or someone would have said that I know that the number of moles can be equal to the number of entities divided by the Avogadro's constant. So that the number of molecules would simply be equal to what? To n number of moles times the Avogadro's number there. And then you input this, and then you get that value. So that was our question paper, guys. And you can see that they say that this question paper was out of what? A grand total of 100 marks. So let's meet once again in the next coming videos. We are going to make more in our revision for our November what? For our November final exams. So keep on studying and also keep on practicing. Use as much exposure as you can get. So come back for more question papers, for more practice so that we can be able to win. So from me, I'll just get to say that more light and more winning up until we meet next time again. Thank you.